Why are heat and temperature not the same? Thermodynamics Basics. Imagine touching a hot cup of coffee and feeling its warmth. Now think about how hot the coffee actually is versus how much energy it has. That's the key to understanding why heat and temperature are different. They are related but serve different roles in thermodynamics. Heat is the transfer of energy between objects because of a temperature difference. It moves from the hotter object to the cooler one. Heat is measured in units like joules and is energy in motion. It's not something an object owns, it's what happens when energy flows. Temperature, on the other hand, is a property of a system. It tells us how hot or cold something is at a specific moment. Temperature is measured using scales such as Celsius, Fahrenheit, or Kelvin. It reflects the average kinetic energy of particles inside the object. When particles move faster, the temperature is higher. When they move slower, it's lower. Think of temperature as a snapshot of how energetic the particles are. Heat and temperature are connected but not the same. For example, a large pot of water and a small cup of water can both be at the same temperature. That means their particles have the same average energy. But the pot contains more total energy because it has more water molecules. When heat flows into an object, it can raise its temperature. But how much the temperature changes depends on the material's heat capacity. Heat capacity is how much energy you need to add to raise the temperature by 1 degree. Different materials need different amounts of heat to change their temperature. That's why adding the same amount of heat to a metal pot and a glass cup results in different temperature increases. To sum up, temperature measures how energetic the particles are on average. Heat is the energy transferred because of a temperature difference. Understanding this difference helps explain everyday things like why ice melts in warm water or how heating a pan makes it hotter. It's a simple but important idea that keeps the world running smoothly in thermodynamics.